All right, so we're going to still talk about some trig stuff, but this one is called applying trig functions. What does that mean, to apply it? Like, why do we learn it, right? What's the use? I wonder that myself sometimes. Not what the use is of trig, because I know there's a lot of uses, tons of uses for trig. All right, so what we're going to do is we're going to solve for some missing stuff. Just like in geometry, remember we had, like, I give you two sides, you got to find the missing side, or you got to solve for x, right? Put things together and that kind of stuff. This is kind of what you've been doing all through math. And we're going to do it again, but it's going to give you some stuff that you would not have enough information before learning trig. All right? All right, so here it is. Here's your triangle, and you got to solve for Q and solve for P. So back in the old days, before you learned trig, what was that, like 2 weeks ago? All right, before you learned trig, could you find Q and P without knowing any trig? No, you couldn't. All right, so you couldn't use Pythagorean theorem, could you? Why could you not use Pythagorean theorem to solve for Q or solve for P? We got all non-talkers left? Somebody's got to help me out. Why could we not use Pythagorean theorem here? Yeah, you got to have at least two of the sides. Exactly right. You got to have at least two of the sides. We only know one side, but we do know one of those angles. Well, we know two. We know that's a right triangle, but we know one of these acute angles, all right? So that's very helpful. We could very easily find the other angle. That would be super easy. How would you do that? You could go 180. That's true. You just go 90 minus, right? So 90 minus 35, and what's that? 55. So if I ask for that angle, you can find that super easy, no trig needed, just basic subtraction. Would you agree? Yeah. What about Q and P, though? Well, what do they tell us? They tell us this is 14. What is this? What is this side to this right triangle? This is my what? Hypotenuse. So this is my hypotenuse, okay? Now, if we're dealing with this angle right here, now you could have used this angle, that 55, but why, right? No real reason to. We can use this one. So what is the Q, side Q? What is that to the 35? If this is hypotenuse, what is the side Q to that 35? It's adjacent, right? This is adjacent. What is the P? It's what to the 35? It's opposite. Very good. All right, so now here's how we're going to use the trig. This is our kind of our first application on why are we really going to need it. Okay, we learned a lot of stuff. We learned like what the sine of 0 was, the sine of 90, the cosine of 270. We've even learned what the cosine of 30 degrees is. We've learned what the sine of 45 degrees is. We learned all that stuff, okay, a lot of that thing. But how is that going to help us? Especially with one that it's not a 45, it's not a 30, it's not a 60, all right? We got to figure out how can we use this to solve for Q and solve for P. Let's solve for Q first. Doesn't really make any difference. There's no reason why we do Q first, then P, but let's just do Q first. So solve for Q. Oops. Solve for Q. I know my Q's are kind of weird looking, but that's my Q. All right. So what do we got? I got a hypotenuse. What are we trying to solve for? Q, which is an adjacent side, isn't it? So I've got adjacent and I've got hypotenuse, right? Adjacent is what I want to find. Hypotenuse is what I know. So which trig function uses adjacent and hypotenuse? The cosine, right. So what you should be doing in your head when you first learn these things is go through this. This should be in your head, right? So which one has adjacent and hypotenuse in it? The cosine does. So how are we going to set this up? We're going to go to the cosine of that particular angle. What angle am I using here? Come on, what angle am I using right here? The 35 degrees, okay? So that's 35 degrees. So the cosine of the angle is the adjacent over the hypotenuse. Which side is my adjacent? That's Q. Over the hypotenuse, which is 14. And now I can do just a little tiny math, little tiny algebra to solve for Q. So how am I going to get Q by itself? Well, what is that 14 doing to that Q? It's dividing, right? Q divided by 14. Agreed? How do I get rid of something that's being divided? I multiply it. So I want the Q to stay there. What do I want to get rid of? The 14. So I multiply both sides by what? 14. And I'm going to multiply that side by 14. Now, technically, you could put a little dot there, a little X to show multiplication. You could put it in parentheses. That would be okay. But you don't really have to. If you just have a number in front of the cosine, what do you think that automatically means we're going to do? We're going to multiply. That's right. This automatically means multiplication. So Q is equal to 14 times the cosine of 35. Well, I don't know what the cosine of 35 is, and there's really no way you can do that in your head. So what are we going to use? Calculator, exactly right. So let's use a calculator. Now, if anybody's watching this on YouTube, you won't be able to see the calculator, but I'll tell you what I'm putting in here. All right, so you can write it in. On a calculator like this, you can write it in exactly the way it looks right here. You could put a 14, then hit a cosine, then hit 35, hit enter, boom, you're done. If you have a little scientific calculator, like I have on my phone, okay, if you have a calculator that looks like this, right, it's got all these trig functions on there. A lot of these calculators, what you would do first, you could do it a couple ways. Here's how I would do it. If I was going to do this on my calculator on my phone, I would hit 35, and then what would you do you think? I want to find the cosine of 35. So I hit 35 first, then I hit cosine, and that should give you a number, decimal number. Then you take that number, multiply it by 14, hit equals, and you'll get an answer. On this calculator, you hit 14 first, then you hit cosine. You don't even have to hit times. Just hit 14, cosine, 35. You could close the parentheses. I like to. I'm a little weird about that. It just looks neater to me. All right. I don't think you really have to. But then you hit enter and boom. Oh, you know what it is? Hold up. I forgot. Have I used this with you guys before? I got to go to mode. I forget this almost every time. Then I got to go to degrees. So I hit enter. Then I can clear it. Now it's in degrees. It was in radians. I don't know if we're going to get to radians in here. We may possibly. So don't worry about that right now. Everything we're doing right now is in degrees. Eventually, if we had enough time in the school year, we would probably get to radians. I don't know. We might get to it in this chapter. We'll see. So let's try it one more time. Sorry about that. 14. It'll look the same except the answer. Okay, cosine of 35. Close that, and boom, there it is. 11 point. Let's just round it to one decimal place. So that would be what? 11 point. What is that? So Q is approximately equal to 11.46. If I round it to one decimal place, what is it? 5. That's right. Okay, that 6 rounds that 4 up to a 5. So that would be your answer. That's how long that side is right there. Okay, and again, it's approximately. So I put a little squiggle equals. That's 11.5. Now, you could possibly do Pythagorean theorem to solve for P, but the problem is this. This is an approximation. It's not an exact answer. So the side for P right there is going to be, yes, it's going to be an approximation, but you're squaring an approximation, which makes it even more approximate, okay? Less accurate, it's probably a better way to say it. So I want to be as accurate as I possibly can. So I'm not going to do Pythagorean theorem to solve for P. I'm going to do a trig function. In fact, doing the trig function, I think is less work and easier to do than doing Pythagorean theorem, to tell you the truth. All right, so let's do P. Let's solve for P. Let's use that same angle. All right, this time, this side is not adjacent. What is it? This is opposite, isn't it? This is opposite, and this is hypotenuse. Which trig function uses opposite and hypotenuse? The sine does. All right, so that's what we're going to do. We're going to go the sine of that angle, which is 35 degrees, is equal to the opposite, which is P, over the hypotenuse, which they told us is 14. Multiply, the math is the same. Multiply that by 14, and now you just plug that into your calculator. So this time, I'm going to go 14 times the sine of 35. So let's put it in. 14 times the sine of 35, and that gives you 8.03. So how do I round it? I want to round it to one decimal place. So what's that going to give me? 8 point what? Does that 3 round that 0 up? No, it doesn't. So we write 8 point what? 0. A lot of people say, well, Mr. Hamrick, is an 8.0 the same thing as just 8? Well, yeah, it kind of is, but this tells me how specific my answer is, how accurate my answer is. This is accurate to the 0 place, okay? Does that make sense? So I know that the number next to it is going to be less than 5. That's what it basically is telling me. All right, if I just wrote down 8, I don't know if that was 8.1, 8.2, 8.4, right? If I just wrote it 8, but 8.0 tells me how accurate I am. So the 0 right there is important. So put that in there. Okay. And that's how we use it. Does that make sense? All right. Now what they're going to do, now they put some minutes in here for the degree, all right, which makes it just a tad more tricky. All right. We'll keep that calculator up. But again, on YouTube, you can't see it, but the people in my class can see it. All right, scooch it over a little bit. All right, let's do a triangle. There we go. So it kind of looks like this. And then to there. Okay, there's your right angle. They use that for R. They use this for 40. It's in feet. This is actually taken from, I think, the beginning of the book. Has a little word problem on there. They talk about it. It's on page 299 if you want to look. There's a picture, I think, on there on page 299. I don't have it in my notes. I don't have it open in front of me, but I wrote that in my notes. But if you want to look at it, that's where it's from. We'll make this X. I'm just showing you all the stuff that they give you. And this angle, it's 52 degrees, 15 minutes. Not even going to deal with that minutes. Well, actually, we could, because that one actually is kind of easy. What do we do if this is 15 minutes and I want to change it to degrees? Do you remember? It's 15 out of what? Out of 60, right? Because 60 out of 60 would be 1 degree. This is 15 out of 60, all right? So it's a fraction of a degree. Make sense? So we do that. And this goes 1/4, right? Do you agree? So if you didn't want to deal with the minutes, since it comes out real nice, and it does kind of come out even, right? It stops at 0.25. So if you wanted to, you could just write this, what do you think? As 52, what? 0.25, and just keep it in degrees. So we got rid of our minutes. We didn't have to worry about the minutes on this one. You okay with that? All right, so that's how we did that. I'll just leave that there. All right, so here's our angle. So really what we're going to do now is kind of what we just finished doing. All right, we got to solve for x and we got to solve for r. All right, let's solve for x first. Well, let's see what is the x to that angle and what is the 40 to that angle, because I don't know what the r is. All right, so I'm not really going to use that one. But if I want to solve for x, I got to know at least one of the other sides. And I do. That's 40. So according to this angle right here, in reference to this angle, what is the 40 to this angle right here? This is what? Is it opposite, adjacent, hypotenuse? What is that 40 to this angle? Is it?
Opposite.
It's opposite. Look, it's opposite this angle. So I got opposite, right? What am I trying to solve for? Solve for x. What is the x to that angle? It's adjacent. So I've got adjacent and I've got opposite. Which trig function uses opposite and adjacent? The tangent. That's how we know which one. Whenever I teach this stuff, the biggest question is always, how do I know which trig function to use? Well, it depends on what they give you in the problem. They give you the opposite side, don't they? And you're trying to find the adjacent side. So you look at opposite and adjacent, you go to that SOHCAHTOA thing, and you're like, which one has opposite and adjacent? The tangent does. The tangent. The tangent of what? It's not just any old angle theta. We know the angle. What is the angle? 52.25 degrees. Right? So we take the tangent of that angle equals the opposite over the adjacent. Which one is opposite? It's 40. Which one's adjacent? It's x. Now the arithmetic on this, the algebra on this is just a little bit tougher, just a little bit, than what we did before. On the one we did before, look where the variable was. It was already on top, wasn't it? So I just got rid of the bottom. That was easy on both of those. This one, where's my variable? It's on the bottom, isn't it? So I got to figure out what am I going to do? And it's pretty basic. It really is. It's not as basic as the other one, but it's still pretty basic. I'm going to get x by itself. Let's see if we can do this in our head a little bit without writing all the steps. I think writing all the steps can be too confusing. So what I'm going to do is I want x up on top, right, as the numerator. So let's take this and put it to the other side. So how would I get rid of it? How would I get rid of this x? It's on the bottom. You're dividing, so you multiply both sides by x. So that would go here, wouldn't it? Agreed? So that goes away. Now, this tangent of 52.25 is just a number. It's a number that I can put into a calculator. That number is being multiplied by the x. How do I get rid of a number that's being multiplied by my variable? How do I get rid of something that's being multiplied? I divide. That's right. So I divide both sides by the tangent of 52.25. Right? It's just like this. If I had 3 equals, I'm making just some number up, x over, or 5 over x. What if I had this and I told you to solve for x? What would you do? I'd multiply both sides by x. Agreed? So that cancels, and then I got to get rid of the 3. How do I get rid of the 3? Divide by 3. So x equals what? 5 over 3. You see that? Yeah, that's basic Algebra 1 stuff right there. No biggie. So it's the same thing up here. Just the number looks a little weirder. It's the tangent of 52.25. It's still a number, just like that 3 was. So how do I get rid of it? I divide. So what do I get? I get x equals 40 over the tangent of 52.25. And that is something that we can just put into the calculator. All right? So let's put it in here. What do you think? We're going to do it just like this. So if you have a graphing calculator, we put it in like this. If you have just a regular scientific calculator, you put it in almost the same. Anyway, let's just do this. 40 divided by the tangent of 52.25. I like to close the parentheses and enter, and boom, there it is. So if I round it to 1 decimal place, so I'm going to put a little squiggle here, all right, because it's approximately, what would it be? 1 decimal, it's 30.97, all right? Watch, 30.97. But what if I ask you to round it to 1 decimal place? Got to put a squiggly there. What's that mean? That 7 rounds that 9 up to a what? To a 10, right? Which means that's going to be a 1, and this is going to be a what? A 0. So it's 31.0. So that's what x is. It's approximately 31.0. We just rounded it to the nearest tenth. We get that? Okay. Now again, this is approximately 31.0. A lot of people would be tempted to do Pythagorean theorem to get r because they're used to it. It's kind of easy, but let's do a trig function to find it. Again, using the Pythagorean theorem means you're going to have to square an approximation. Squaring an approximation makes it more approximate, right? So I don't want to do that. Let's use the trig function and solve for r this time. We're going to use this angle. We already knew this was 40. It's exactly 40. So look what I have. I got opposite and I got hypotenuse. So which trig function are we going to use with opposite and hypotenuse? We've already used it once. That would be the sine. So we take the sine of 52.25 and set it equal to the opposite, which is 40, over the hypotenuse, which is r. Look, the arithmetic is the same. When your variable is on the bottom, after a while, you get used to this algebra very, very quickly. So the r goes over here, and the sine of 52.25 goes underneath. So what is r then? It's 40 over the sine of 52.25. You see that? So that arithmetic was a little bit harder than the one we did earlier. Okay, not this one. It's the kind of the same exact thing. All right, the one we did earlier in the class. So we move the r over here. That goes on top. Take the sine of 52.25. KJ, can you open that door? And then you divide it by the sine of 52.25. Now, you put that into a calculator. So let's do it. So I put 40 divided by sine of 52.25. 52.25. Close parentheses, hit equals, and there you go. It's about 50 point what? If we round it to one decimal place. Make a squiggly equals. 50 point what? 6. 50.6. See that 8 rounds out 5 up to a 6, and there you go. So that's what r is equal to, approximately equal to. This is what x is approximately equal to, right there. And that's the kind of stuff that they want you to do. It gets a little trickier. That was real basic, all right? Gets a little trickier. Because the reason we learn this stuff is we can put it into practice in a real life situation. Now, this one that we're going to do right now probably doesn't look like a real life situation, but it is. So what's that? 1, 2, 3, 4, 5. So here's a pentagon. All right, there's a pentagon. And you have a circle that circumscribes the pentagon. Anybody remember what circumscribed meant? What's the circle going to do? Is it going to go inside the pentagon? Nope, it's going to go outside the pentagon. So might have to make some adjustments on this. So let's take this, bring it out to here, bring this out to there, bring this one, might have to move it up a little bit. See what I'm doing? Yeah, does that look like it hits? Yep. So we say that pentagon is an inscribed pentagon. It's inscribed in that circle. Or you could say the circle is circumscribed, meaning it goes outside the pentagon. But look at all the vertices. All the vertices meet right at the, on the circle. That's what I was trying to say. Let me put a center right there. And what I'm going to do is I'm going to draw from here to here, and then from there to there. So that's basically the radius of the circle and the radius of this pentagon. Would you agree? From the center to this point where the vertices meet. Yep, so that's a radius. And what are they asking you to do? They're asking you to find, let me see what this looks like. Do they give you a picture with this? Oops, wrong book. Does anybody have that open? Anybody have the book open at all? Wasting time now. That's okay. What lesson's this? 5-4. 5-4. Example 3. Let me see it. Oh yeah, they don't really apply this to anything. They just give you this stuff. All right, that's good. That's why I didn't write anything else down. So what they're going to ask for is they're going to ask to find the apothem. Remember that from geometry? I just taught this in my CP geometry class today, all right? So it's fresh in my mind. Maybe not yours. It's been 2 years. But the apothem does this. It goes from the center and it's perpendicular to the side of the pentagon. Everybody see that? Tell you the truth, the circle doesn't really have a whole lot to do with this thing. They just tell you the radius of the circle, so the radius of the pentagon is the same thing as the radius of the circle. So yeah, yeah. All right. So here, this is what we're going to do. I did this in geometry today, in CP geometry. If you want to go to one of my CP geometry classes, I'll go into a little bit more detail of that, but let's see if we can remember anything. Yep. So what I'm going to do is I'm going to find the apothem. That's the red. All right, and let's make this another color. So I'm trying to find that red line. I'm trying to find out what the red line is equal to. And the only thing they tell you is the radius. Let's see. Yes, they tell you the radius of this circle or pentagon, and it's 4.17. All right, so that from here to here is 4.17. And that's all they tell you. That's it. Okay, and you have to find the apothem. Okay, how in the world are we going to do that? Well, you see a right triangle there, don't you? All right, so that's nice. The problem is, I know one side. That's not a problem. That's a good thing. I don't know this side. I don't know this side. But I don't know an angle either. So I'm kind of stuck. But if you remember from geometry, if this is a pentagon, watch. If I took a line out to here, and to here, what is that whole big angle right there? The circle, which is 360, right? So what is the part right here? It's broken up into 5 different triangles, isn't it? So this would be 360 what? Divided by 5. Very good. And that gives you 72 degrees. So that's that green angle. But what am I trying to do? I'm trying to find the red, which is one of the sides of my right triangle. So I need that little angle right there. Okay, not the whole big one, but that's going to help me. So what's that little one right there? Yep, which is 36 degrees. Okay? Everybody see that? So now, let's draw this kind of by itself. All right? So I've got, there's my apothem. There's half the bottom of it, and here's that 4.17. All I'm doing is just redrawing it so I don't have all that junk in there. It just kind of makes it hard to see. So what's this angle? 36 degrees. And we figured that out on our own. The only thing they told us was this was 4.17. That's the thing they told us. And I want to find A. Now, in my CP geometry class, they wouldn't have been able to solve this. In fact, I told them the only one that you're going to be able to solve is a 30, 60, 90 triangle. And if it was 45, 45, okay? But they would not be able to do this in CP geometry. You can do this now because you know a little bit of a trig. So let's do it. Can I solve for A if I have this information? Should be able to, right? There's one side, there's one angle. I should be able to solve for everything else now. All right, 4.17, that's my hypotenuse. What's the A to that 36 degrees? Is it opposite or is it adjacent? It's adjacent, okay? This is adjacent. It's next to it. This one's opposite, okay? I'm looking for this. That's what I'm trying to find. So it's adjacent. I got adjacent and hypotenuse. Which trig function do we use with adjacent and hypotenuse? Cosine. The cosine. Very good. So the cosine of what? 36. That's right, because this is adjacent to the 36. All right, so I use the 36. The cosine of 36 equals the adjacent, which is A, over the hypotenuse, which is 4.17. Now the math is super easy. If I want to get A by itself, I have to get rid of 4.17. So I multiply both sides by 4.17. Everybody see that? All right, and now plug it into the calculator and I'm done. I got the answer. I got what the apothem was. Let's put it in here. So it's 4.17, cosine of 36, I like to close the parentheses, equals 3 point, round it to one place, what would it be? 3 point what? So A is approximately 3.4, whatever it's in. I don't even say what it was in. Oh, the 4.17. That's all right. It's no big deal. What they did, I didn't even notice this. They told you the diameter of the circle. They told you the diameter of the circle was 8.34. How in the world did I get that 4.17? If they told you the diameter, this is the what? The radius. Okay? So it just took half of that. That's where we got the 4.17. Okay? So sorry about that, but that wasn't really that big of a deal. They told you the diameter of the circle, and so this right here has to be the radius of the circle. It's just half the diameter. That's easy. So it's 3.4 centimeters, because they told you this in centimeters. I didn't tell you that at the beginning, but now I did. And there you go. And you got that right there. Make sense? All right. Oh, there's no way in the world I'm going to be able to do this next problem in the time that we have. We'll save that for tomorrow, okay? So remind me tomorrow to do example 4.
The PTS will be having a pretzel sale this afternoon at 3 o'clock in the lobby. Soft pretzels are $1 each.
Okay, so example 4 we will do on Tuesday.
They will be tomorrow morning at 8 a.m., so please make sure you are in time.
Here's what I want you to do for homework.
Device that you are using. And then the final message is the National Junior Honor Society is holding a bake sale tomorrow morning in the upper school lobby before school, and they will also have it at lunch in the upper school lobby as well. Thank you.
There may be a couple that we haven't covered here because we only missed that one example 4. Maybe I'll hit it first thing tomorrow. All right, so try your very, very best to do as many of these as you possibly can. There's not going to be one of these. It's not going to be one of these assignments where you're doing like the same one over and over and over again. Okay, you've had those before, right? Where you do one, the next one looks just like it, the one after that looks just like that. It's not like that, all right? So you're going to have to think a little bit on these. Put some time and effort. Look, I know it's prom week. I get it. But the next couple days, we're going to work, okay? We're going to work through Wednesday. I'm not going to give you any homework on Wednesday, all right? So you don't have to worry about doing anything over the break or anything like that. But I want to do at least 2 lessons, okay, before the end of this week. I want to do this lesson. We'll try to finish this up tomorrow. Then I want to do the next lesson after that. Then after that, you're done. Enjoy your prom. Have fun. Right? Enjoy your Easter break. I'm not going to give you any homework over Easter break. Don't worry about any of that stuff. Okay, I would never do that. But please, try your best. Try your hardest at these and don't quit. Okay, it's not over yet. Once this class is over this week, then it's over, right? Until you come back from Easter. So you don't have to worry about it. So put a couple days of work into it this week. Yes? Example 4? The one before this? Yeah. You just solve for A. That's all they wanted you to solve for, that red line right there. That's all they wanted you to find. Okay? The next one, though, it's a little tough. I thought about not even doing it. That's why I think I can give you this homework, because I was thinking about not even doing that. I don't know if you have anything this tough, like example 4. But it's good to do. It's good to do. All right? Yes, sir.